Hi, my name is Amit Singh and today I'm going to be giving you a demo on how to troubleshoot using the CLI in the Adaptive Cloud Fabric. We will show you how the CLI provides unique advantage and leverages the fabric. So here I have a leaf and spine fabric configured, as you can see in the topology. And then I have core and border leaf nodes which are part of separate fabrics. I'm going to log on to one of these nodes and try and find a MAC address, a specific route, STP related issues, and show an example how using the Fabric CLI enables your troubleshooting to be a much more simpler task than logging into individual nodes across multiple devices or even using a cumbersome UI. Let's get started with the layer 2 troubleshooting section. Here we are going to look at how do we troubleshoot endpoint MAC related issues, ARP, and STP related issues. These are going to be simple examples to show you a quick demo. So let's get started and log into the CLI. So I have three screens open out here. Leaf 1 in the main fabric, spine 2, which you saw earlier in the topology, and core 1. So leaf 1 and spine 2, as you can see from the fabric node output, belong into the same fabric. And core is part of a separate fabric. I'm going to look up a layer 3 interface on the spine, and I'm going to try and find a MAC address based on there. So as you can see, the core is directly connected to the spines. So I'm going to copy this MAC address for the specific IP 10.60.26.58, and I'm going to see where this MAC address has been learned from. So as you can see, the MAC address has been learned using VLAN 3000, 3008, 3030 across multiple interfaces via the spine nodes. So that's the layer 3 MAC address, layer 3 interface MAC address on the spine, and you've logged in from the leaf and you're able to troubleshoot and find the MAC address. The same would apply to any endpoint host as well. It could be logged in on any leaf node, and you could log into any node in the network and find out where the MAC address sits. A vport history MAC show also shows you a history of the MAC address table, and it gives you a time when the MAC address was first seen, when it disappeared from the hardware table, when it reappeared. A whole history is tracked. This allows you to troubleshoot complex ARP, storm, or loop issues, because now you can find out where a MAC address is coming from, where it's being seen, and you can log into a single place and see it. You do not have to go step by step to look at where the MAC addresses have been seen. So within one screenshot, you saw 4 switches showing you how they've learned the MAC address. Now let's look at STP port show. I only am concerned about port 10. That's where, let's say, my specific application is connected. As you can see, STP port edge, is basically spanning tree port fast mode, has been disabled. I can go ahead and use switch star, which will go ahead and apply the configuration to every single node in the fabric, or I could even specify individual nodes or a group of nodes. I've went ahead and used switch star. Now let's go ahead and look at the configuration again. And that's it. As you can see, all nodes are now spanning tree port fast mode enabled. So within a few quick steps, you can troubleshoot the entire set of nodes in the fabric or in your pod. Okay. Now let's look at layer 3 troubleshooting, how the fabric would enable this. So let's log in back into the CLI. This time around, we'll log into the border leaf first, as shown in the topology. We're going to look up a specific VLAN IP address of that specific VLAN, which is VLAN 1111. The IP address is 11.11.1.1. Okay, so we look at the specific VLAN IP. We're going to go into the core node. So the core node sits on a separate fabric than the leaf and spine node, and also the border leaf node. So you do a quick vRouter route show network, and this is how it would appear on a non-fabric enabled device or any non-fabric enabled vendor device. Now let's log back into the spine, which is part of the fabric as shown earlier. And I have multiple vRouters configured here. vRouters are basically multiple VRFs. Now let's go ahead and look at the vRouter routes on the spine node. So we are again looking for the routes learned from the border leaf 11.11.1.1 subnet. So I have 7 vRouters configured, or 7 VRFs configured. All of those VRFs are actually learning all of these OSPF routes. Okay, so here you go ahead and you see all of the vRouters from all of the different spines. I have 4 spines, and all of them have actually learned the route using OSPF. So within a single snapshot, you are able to figure out if every single node in the fabric has learned the specific route or not. Now let's say you have more nodes in the fabric and you do not have the time, let's say, to browse this one by one. You could make it more simpler for you and do something like count output. So I have 4 fabrics, 4 spine nodes which are learning the route, and 7 vRouters configured, or 7 VRFs configured on each of the 4 spines. So I just do a count output, and as you can see, I have 28 nodes or 28 VRFs which have learned the routes. So if any one of them were missing, now you can just look for the missing ones and troubleshoot it. So that's it. Thank you for watching the video.